So by transforming the three-phase vectors into two DC vectors, what we have also done is that we have transformed the three-phase windings. Say, for example, we have a set of star-connected three-phase windings. We are transforming these three-phase windings to two fictitious windings, uh, wherein you are applying the voltage VQ and VD. Fine. So these were our three-phase starter windings, say for example VAS, VBS, and VCS. So what we have done is from three-phase we have converted. So we cannot actually transform the windings to two windings. Uh, so we are just assuming this has done. This has been done mathematically. We are transforming the three-phase real windings to two fictitious windings that are located 90 degrees in space from each other. So accordingly, the voltage that will be applied to these two fictitious windings will be VQS and VDS. Fine, and the superscript E here will refer to the uh, synchronously rotating reference frame. ये जो ऊपर वाला E है, this refers to the synchronously rotating reference frame. This S here refers to stator windings. Fine. Now we have transformed VAS, VBS, VCS to VQS and VDS. Using the same formulas, we can transform IS, IBS, ICS to IQS and IDS, and we can transform PSI-AS, PSI-BS, PSI-CS to PSI-Q and PSI-DS. Fine. So if we are talking about this winding here, once we apply the voltage VQS to this, a current IQS will be flowing through this winding and IDS will be flowing through this winding. So, uh, and let the starter resistances be RS. So we can say the KVL, once applying the KVL to these fictitious windings, we'll be getting VQS is equal to mm, superscript S here refers to stationary reference frame. VS, VBS, VCS therefore is transformed to stationary reference frame. So the superscript S refers to the stationary reference frame. So the KVL, by applying the KVL, we'll be getting VQS S will be equal to RS IQS plus d by dt of psi QS. So you can actually write plus L di by dt, or you can write d by dt of psi QS as psi QS is flux linkage. So an AC voltage VQS S superscript S refers to stationary reference frame. So this is still an AC voltage. So associated with an AC voltage will also be the flux component, the flux linkage. So d by dt of psi QS uh, S, and similarly VDS phase. You can say them. There are two phases here. VDS RS IDSS plus d by dt of psi ds. Fine. So we have three phase AC windings VA, VB, VC. तो VA, VB, VC में हम जब KVL लगाते हैं, we say VA is called IA or IARS plus d by L d by dt L d di by dt. Fine. ऐसे ही दूसरे फेज में, ऐसे ही तीसरे फेज में. So yeah, here now we have two phases, two orthogonal phases VQSS and VDSS. So accordingly, we'll get these two KVL equations. VQSS will be RS IQSS plus d by dt of psi q SS, and VDSS will be RS IDS plus d by dt of psi ds. Fine. So these uh, so VQS and psi QS and psi ds, they refer to the Q axis and the D axis stator flux linkage here. So VQS VDS तो हमने कैलकुलेट किया था. IQS IDS की सेम फॉर्मूला होगी, psi QS IDS की सेम फॉर्मूला होगी. There will be no difference in these. So applying यहाँ पे go back to your notes, you'll find out VQSS and VDSS. So this is actually VQS and VDS that we have already calculated. It's equal to VQS E cos theta I plus VDS E sin theta I, and VDSS is minus VQS E sin theta I plus VDS E cos theta I. So equations 5 and 6. By applying equations 5 and 6, remember when you have derived an equivalent circuit of induction motor, you have derived a per phase equivalent circuit. Fine. So if you were drawing a circuit like this, so the applied voltage here was, say for example, VA. This was your starter resistance. This LS actually denoted your starter flux losses plus the starter flux inductance as starter inductances plus starter flux losses. So VAS was IA RS plus LS plus d by d L di by dt. Fine. And assuming the core, if you were assuming the core only inductive in nature, you can say it is plus LM uh, प्लस एल एम इंटू डी आई एम बाई डी टी. तो अगर हम इस पे के वी एल लगाएंगे इन लूप वन, यू कैन से वी एज आई ए आर एस प्लस एल एस डी आई ए बाई डी टी प्लस एल एम डी आई एम बाई डी टी. Fine. So you could have combined these two reactances to form a single flux linkage component. So similarly, now we have two phases only, VQ phase and VDS phase. So accordingly, you can apply the KVL equation. So अब VQ क्या किसके बराबर होगा? It will be equal to IQRS plus you could have denoted this as well as D psi S by dt. Fine. So it आपकी जो equation थी, even in the VA would have been equal to IARS plus D psi S by dt, where psi S would refer to the total flux linkage, uh, both the leakage flux component as well as the magnetizing flux component. Fine. So IS is actually the leakage flux component as well as constituted of the magnetizing flux component. So similar equations has been applied to psi q to these two phases VQ and VD. So we are getting RS equal to IQS plus d by dt of psi QS. Now applying equations 5 and 6 here. So say for example I am applying equation 5 in equation number 12. This This is equation number 12. This is equation number 13. Equation number 5 I'll be applying in equation number 12, where equation number 5 is VQSS is equal to VQSE cos theta E plus VQSE sin theta E. हमने जो लास्ट टाइम इक्वेशन निकाली थी वो यार डिराइव्ड वी क्यू एस इक्वल टू वी क्यू ई कॉस थीटा प्लस वी डी ई साइन थीटा ई. ये जो नीचे वाला सबस्क्रिप्ट था एस, ये वहां पे मैंने नहीं दिखाया था बिकॉज this could either refer to the stator windings or this could refer to the rotor winding. Now we are specially taking the stator winding voltage and converting them into VQS and VDS. So this subscript S now here refers to the stator uh, quadrature and direct components. So VQS S is equal to VQS E cos theta E plus VDS E sin theta E. So this superscript S refers to stationary reference frame. This superscript E refers to the synchronously rotating reference frame. Now applying this equation in equation number 12, what we'll be getting is VQS S की जगह पे we'll be getting VQS E cos theta E plus VDS E sin theta E is equal to RS IQSS जैसे VQSS हमने निकाला IQSS भी सेम ही होगा. IQSS will be equal to IQSE cos theta E plus IDSE sin theta E. So instead of writing IQSS, I'll be writing IQSE cos theta E plus IDSE sin theta E. Fine. So these equations VQ हमने खाली एक जनरल इक्वेशन निकाली थी VQS and VDS, VQE and VDE. Now you can apply them to any state variable of the induction motor. There will be no difference. Fine. So IQSS will similarly be equal to IQSE cos theta E plus IDSE sin theta E plus d by dt of psi QSS. Psi QSS will similarly be equal to psi QSE cos theta E plus psi DSE sin theta E. Fine. So this was my equation number 5. I have applied this in equation number 12. The general form of equation number 5 has been applied in equation number 12, where IQS will be denoted in a similar fashion. So IQS will be denoted in a similar fashion. Fine. So what will this give me? VQSE cos theta E plus VDSE sin theta E equal to IQ RS times IQSE cos theta E plus RS times IDSE sin theta E plus d by dt of psi qs E cos theta E d by dt of psi qs E cos theta E plus d by dt of psi ds E sin theta E d by dt of psi qs E cos theta E plus d by dt of psi ds E sin theta E. Evaluating these two terms, d by dt of psi qs e cos theta e is nothing but cos theta e sa d by dt of psi qs e plus psi qs e sa d by dt of cos theta e. That's equal to cos theta e d by dt of psi qs e plus d by dt of cos theta e की जगह पे मैंने ओमेगा ई टी लिखा. So once you do the differentiation of this, internal differentiation will be omega e. This will be omega e psi qs e d by dt of cos is sine. It will be minus sine d by dt of psi qs e. Now this component psi ds e sine theta e. Psi ds e sine theta e will be equal to sine theta e sa d by dt of psi ds e plus psi ds sa d by dt of sine theta e, that is again omega e cos theta e. Fine. So this is equation 13, this is equation 14, this is equation 15. So applying 14 and 15 in 13 and comparing coefficients of cos theta e and sin theta e, applying 14 and 15 in equation 13, and from there compare the coefficients of cos theta e and sin theta e on both sides. You will be getting two equations. One equation will be VQSE equal to RS IQSE plus d by dt of psi qs plus ओमेगा ई psi ds. ठीक है, ये cos थीटा ई के कोफिशिएंट्स दोनों साइड पे होंगे. ऐसे ही sin थीटा ई के कोफिशिएंट्स दोनों साइड पे VDS E will be equal to RS IDS E plus d by dt of psi ds plus omega e psi qs. Minus 13, 14, 15, 16, 17. So these are the starter equations. So similarly, for omega r equal to 0, that means rotor is not rotating, we'll be getting V Q R E. Okay, will be equal to R R I Q R E plus d by dt of psi q r plus omega e psi d r. Fine. and VDRE will be equal to, खाली हमने क्या चेंज किया, सबस्क्रिप्ट चेंज किया. For rotor side the equations will be VQR and VDR. For the stator side the equations were VQS and VDS. RR equal to IQRE. Now this will be equal to RR IDRE plus d by dt of psi dr minus omega e psi qs psi qr. These equations will be valid only when the rotor is not rotating, but when the rotor will be rotating at any speed, say for example, यहाँ पे omega e psi dr था. Now it will be omega e minus omega r. So the relative speed between the stator and rotor will be omega e minus omega r times psi dr. For omega r equal to 0, this omega r will simply be 0 and this equation will be plus omega e psi dr. But in case omega r is some positive definite value, or even you will have to place omega r as such. Omega r d by dt of psi dr plus omega e minus omega r psi qr. ठीक है. और ये जो सारी वोल्टेज हैं या करंट्स हैं, दे we have calculated them in the synchronously rotating reference frame. Fine. So equations number 16 and 17 and equation number 18 and 19. These equations denote the dynamic model of induction motor. Now using these equations you can actually draw the per phase. Now by referring to the per phase, जैसे हम पर फेज ए फेज का इक्विवेलेंट सर्किट बनाते हैं, बी फेज का, सी फेज का, यहाँ पे अब आपके पास क्यू फेज है और डी फेज है इन शॉर्ट डायरेक्टली. सो उसका फिर एक आप स्टार्टर साइड दिखाते हो और रोटर साइड दिखाते हो. ऐसे आप क्यू का स्टार्टर और क्यू का रोटर दिखा सकते हो. सो यू आर अप्लाइंग अ वोल्टेज वी क्यू एस. फर्स्ट रेफर टू इक्वेशन नंबर 16 जो हमने निकाली, that's VQS E is equal to RS IQS. That means this current is flowing, there is a current IQS E that's flowing through a resistance of value RS. So VQS is equal to RS IQS plus d by dt of psi QS plus psi E omega ds. ठीक है. omega E psi ds VQS was equal to IQS into RS plus omega E psi ds plus d by dt of psi QS. So the total flux linking this uh, inductance and this inductance will be psi QS. So say for example, we refer to this as LLS. This will be our LM, the magnetizing inductance. So इसका total flux linkage कितना है? IQS. So the current flowing through this is IQS. So हमारा जो total KVL यहाँ पे है, that is VQSE is equal to RS IQS plus omega E psi ds plus d by dt of psi QS. ऐसे ही फिर आपका रोटर साइड था. रोटर साइड पे आपकी जो आउटपुट इक्वेशन है, that is output equation at the rotor side is VQRE. VQR is equal to IQRERR. So a current IQRE is flowing through a resistance of RR plus VQR is also consists of omega E minus omega R. It consists of this drop, omega E minus omega R psi dr drop plus d by dt of psi q r. Fine. So we have two equations. One equation is this. This is referred to the stator side voltage KVL equation of the quadrature component. VQS is RR IQS, RS IQS plus d by dt of psi QS plus omega E psi ds. ठीक है. So these are all voltage quantities. Psi is voltage. ऐसे हमारे पास equation VQRE है. So using equation number 16 and 18, we have derived the Q equivalent circuit. VQS is equal to IQS RS plus omega E psi ds plus d by dt of psi QS. So psi QS में दो इंडक्टिव कंपोनेंट्स है. एक तो मैग्नेटाइजिंग इंडक्टेंस है ही, दूसरी जो आपकी LLS है, दैट इज एक्चुअली द स्टैटर फ्लक्स लिंकेज. ठीक है, दैट यू ऑलरेडी नो फ्रॉम द equivalent circuit of induction motor. And similarly, on the rotor side, you have the rotor flux linkage. You have the magnetizing component that will constitute the d by dt components that will constitute psi qr, and you have a voltage drop equivalent to omega E minus omega R psi dr plus another voltage drop equivalent to RR IQR. ठीक है. So this is the per phase equivalent circuit of QXC is equivalent circuit of the induction motor. So this refers to, now this is a dynamic model of induction motor. So using this equivalent circuit, you can actually analyze the transient behavior, and also you can, using this circuit, you'll be able to find out that you can also use this circuit for vector control of induction motor. So ये तो हो गया आपका Q equivalent circuit. Similarly, ये आपका क्यू इक्विवेलेंट सर्किट हो गया। आपका डी इक्विवेलेंट सर्किट, VDS इक्वल टू IDS RS प्लस psi E प्लस ओमेगा E psi QS प्लस L प्लस D by dt of psi DS, ऐसे VRE इक्वल टू IDR RR प्लस ओमेगा E माइनस ओमेगा R psi QR प्लस D by dt of psi DR। ठीक है, these are all in a synchronously rotating reference frame। LLS, LLR, LM, बाकी वो सब कुछ same है, and there is only one difference, that is in this sign. There is this sign that you have to take into care। ठीक है, so इस साइन की वजह से खाली ये जो वोल्टेज ड्रॉप्स हैं, these are negative, these are subtractive in case of D axis, whereas in case of Q axis these voltage drops are additive। Fine, so these are the Q axis and the D axis dynamic model of induction motor। So using this model you can find out the transient behavior of induction motor, uh, and using this model you will be able to derive the vector control of induction motor। So that's all for today.